Hello guys and welcome to my YouTube channel. Today I'm going to tell you about forging topic. Now this is an assignment, so it will be more informative and study oriented. So if there is any problem in your understanding, you can tell me in the comment box and I will reply that so. Now I welcome you to my PPT for forging. Let me give you a short intro about myself. My name is Sai Sagar Survey and I am a SY student of BTech Mechanical. My college name is College of Engineering Pune. Now, from being a science student, I would ask two questions to forging: that what is forging and how it is done, and the definition itself gives answer to both these questions. It goes like: forging is basically refers to a process of shaping a metal block by means of compressive forces. Now in forging process we will encounter compressive forces which are used to compress or shape the metal block. Now heading on the classification to the forging are carried out at two temperature, or we can say two state. Some metals require high temperature to deform and get the shape without any flaws or cracks. These metals are operated at hot forging, and metals which are not needed to be heated and then forged, these are included in cold forging processes. Now this metal cold forging process metal includes some metals which are relatively ductile and malleable than iron and steel and can be deformed by applying comprehensive forces beyond the elastic limit without any flaws or cracks. So it goes like cold forging process and hot forging process. Then moving forward to the equipment used in forging processes, there are majorly dies used to give the desired shape. We can't use a single plain hammer, so it will be easy for us to use die. Now there are two types of die: open die and closed die. In open die, metal between the dies is allowed to expand laterally, and the compressive forces are forcing it not to expand longitudinally. In case of closed die forging, there are some pipelines where the metal can expand. These pipelines are providing a path for the flow of flash. Now flash is the excess material. As we can see that if we put some metal which is beyond the limit, then we can trim the metal job to its desired shape. But if we put metal which is not beyond the limit and it is lacking in some grams or milligrams, then we can't get a desired shape by any means. So these excess metals are seen in closed die forging, where it is called flash. Now flash allows us to get a neat and without any cavities job. I will explain it in further. So heading on to the examples of drop forging. In drop forging, the metal job which is heated depending upon the metal, as I said earlier, is placed between two dies. In here we can say that these die are plane in structure. So when job is placed, the rammer is raised to a certain limit and then dropped. Thus this deforms the metal job to a shape which is required. Now as you can see here that the job which is created, it is simple in structure, so we can conclude that the job which we can create from drop forging are simple, and complex needs another process. Now heading on to the press forging. Now press forging is a revolutionary process which is used extensively in industries, where there is constant application of load on the rammer so as to compress the metal. Now this is efficient because there is a continuous need of torque required, and it gives more efficiently than drop forging because there is no chances of breaking the metal due to gradual increase in compressive forces. Now heading on to further, impression die forging. Now this is a extensively used process in machines because in this process we can get a desired job by just pressing between two dies. Now this impression die forging is used for the jobs like our spanner in our toolbox or any screwdriver, where we need a complex structure which can't be manufactured through any for recent process like drop forging or press forging. Now here we can see that there are two dies and there is a hot billet placed between them, and it is pressed with the impression die, or we can say upper die, and we get the desired job by ramming continuously for several times. And thus we can see here there is a flash. As I said earlier, this is the plane is flash. Now this flash, as you can see, the at the borders it is getting cooled. Now this cooling forces the inner material to remain inside and give a cavity, giving us a job with flawless without any error in it. Then heading on to further, there is upset die forging. Now upset die forging is similarly to impression die forging, but here we can see that the job is heated and put between the two dies. This is called the supporting die because it supports the die, and from the forward side it is compressed. Now this increases the diameter of the job and satisfied the need of upset forging. So moving further, what are the effects? Now this is the main topic which we need to clarify neatly, because the effects on metal of hot forging and cold forging are the necessary needs for you to select which forging is needed. Now in hot forging, as you can see, the grain structure which is seen here, it is a bit flowing through the all part or the job. Now these ensures that there is homogeneous density of metal throughout the job, and it gives a continuous strength for the job. As we can see, there is this slide shows that due to co-forging, hot forging, the strength increases, of course. Then there is low strength. It means that it will change its dimensions very rarely in pressure, under pressure, which are higher than its comprehensive forces. Then it is less ductile, and as we can see, due to low strength, it is less ductile and prone to any mechanical process. Now if we go start to drill such a job, it is tough for us to drill through the it. Now effects of metal on cold, effects of cold forging on metal implies us that when we cold forge the metal, the grain structure is not homogeneous. As we can see, the metal is not heated, the outer layer gets compressed and increase the mechanical strength, but the inner layer remains as it is. Now this gives very high mechanical strength due to as the outer layer are only compressed, but it is most likely to flaws and cracks in it. Now there is an advanced forging method which is roll forging, and this roll forging is done extensively in case of a rod where we need to vary the diameter. Now as we can see, there is a pattern over the roller, and this gives us the desired shape on the rod. And this forging is very efficient because rather than spending time in on the forging process, roll forging can decrease the diameter by rolling means, and can be efficient in case of bar. This gives us the ability to decrease the diameter and shape the metal gradually and efficiently. As we can see, the metal is efficiently and homogeneously shaped, so there is no flaws, and it is cost efficient as it is rotary motion. So by using gears we can manipulate its speed, and what speed is basically needed for us, we can see it easily. So moving forward, thank you for watching my video. If there are any doubts, you can ask me in the comments. I will give you some links in the description. These videos were from the another channel which I had seen, and I will prefer you to see their videos. There are many more animated videos which are very informative, and I wish you to see them also. Thank you.